It's fairly daunting for me to be here really today, and quite an amazing honour. I'm one of these people who is an introvert, and I tend to like to sit in a little corner and think about things and solve the world's problems by myself. And I never imagined at all that anybody would really be interested in what I think and any ideas that might have come out of my PhD until I spoke to Adam Harriet down here sitting here videoing. And he seemed to think that maybe, yes, I do have some ideas that are worth sharing, and this might be one of the best places for me to do it. So I'm incredibly grateful to Adam for giving me a lot of stress. Coffee beans. I'm a landscape architect. It seems to be a conflict between landscape architecture and hiding in a corner and thinking, but that's what I do. And I'm fascinated by patterns, the patterns of the world around us, and not just the patterns of the environment, i.e. natural environment and built environment, but the patterns that they create within people as well. And what do I mean by people patterns? Well, I'll give you an example. Although you've heard some examples today in the talks, I get up at 5 o'clock every morning. I let the dogs out to go for a wee, come back in, I put the kettle on, turn the coffee machine on, unpack the dishwasher. I go back and let the dogs back in. Then Robin, who is in the audience here, my wife, we make coffee. We sit down and watch the ABC News on Channel 24 every morning. And that's our pattern, every morning, Monday to Friday. But within that pattern, there are slight changes. I might let the dogs out first, unpack the dishwasher, I might put the kettle on, then let the dogs out. So there are slight changes within that routine. And we all live by these sorts of patterns. Christopher Alexander once said that he can describe most people's lives by about 10 or 12 patterns, but you can break those patterns down. One person who understood patterns better than anybody else, who died just recently, was a French mathematical physicist called Benoit Mandelbrot. You might have heard the name. He actually found something completely new about the patterns of natural systems and environments. He discovered they worked on a completely different sort of geometry to the geometry we use to develop all our systems and processes, our buildings, and the geometry you're taught at school in terms of how to draw circles and squares and triangles. He discovered a geometry which he called the geometry of nature, and it's a geometry we call fractal geometry today. Now, you don't have to worry about the term. I'm not going to talk about fractal geometry, but just something that really came out of it, which has changed the world. An important finding that Benoit Mandelbrot came up with out of his studies was this concept of self-similarity in patterns. And self-similarity is fairly easy to see. Up here we've got Romanesque broccoli, quite a common vegetable in Europe, not so common over here in Australia. And you can see the pattern of the Romanesque broccoli. The whole pattern is very similar to the pattern within the individual florets. And then if you zoom into the individual florets, you'll see the same pattern. And so this concept of self-similarity means that as you zoom into things, you see the same pattern again. You zoom deeper, you see the same pattern again. But self-similarity can also be looked at in another way. People have existed on this planet for millions of years, thousands and thousands and thousands of generations. Yet we all have 2 arms, 2 legs, 2 eyes, a nose, a mouth. We all have 2 ears. We're all similar in that respect, but we're all different. We're all of us each unique individuals. So self-similarity can be looked at over time as well as over space. Mandelbrot characterized this concept of self-similarity by a number he called the fractal dimension. It's not important, we'll just call it the fractal value. It's just a number that goes up and down, which classifies and helps to understand the level of complexity and fractal dimension, the level of complexity and self-similarity. But why are these patterns important to us? Why are the patterns of nature and the environment important to us as people? In the 1980s, a guy called William White, who was a planner in the urban department of New York City, wrote a book about urban spaces. And he came to the understanding, after many years of studying, he looked at people and how they use spaces, he did target photography. He came to the conclusion that as designers, myself, architects, engineers, we have a moral responsibility to design public spaces that enable people to work within a civic framework, to enable people to engage together, to enable communities to engage together. As a rule, we tend to prefer the patterns of nature over the patterns of our modern built environment. They tend to be more restful, more relaxing, they tend to be restorative, And what we mean by restorative is that when you go into nature, it rests your mind, you can concentrate again, you can refocus your energies. That's why we go on holiday. We go on holiday to escape the city, we go on holiday to the beach, we like walking on the beach, we go to the forest, we go to the Daintree. We go to old places, old cities that are not like the cities we build today. You've had a really bad day in the office. This is 2 scenes from Harvey Bay. You're really frustrated, you're really stressed out. You want to go for a walk to try and recover. Which of those 2 places would you rather walk down? Which of those 2 places do you think would help you de-stress and recover from the really bad day you've had? I think I know which place I would rather walk down. I don't know about you. Understanding patterns, I believe, is essential, and the processes that drive those patterns is essential for us to be able to design future environments for the world. The World Health Organization says that by 2030, 6 or 7 people out of the globe will be living in urban environments. And it's my contention that we're designing urban environments today that actually cause people stress. They don't help people to relax. They don't help people to work and try and obtain a work-life balance, as the last video said. I've studied 21 environments around the world, ranging from high-density urban environments up to regional parks. And I characterise those using Mandelbrot's concept of this self-similarity. And you can see that Melbourne Docklands rates the lowest, and Regent's Park rates the highest. And there's a couple of photographs there which sort of indicate what those patterns were like. Now, the patterns of nature are not something that's really designed per se. They're the result of many, many different types of interacting forces. Like when a plant grows, if it's seeded by a bird having a poop in a tree, it grows up. It's subject to all the soil forces, it's subject to all the weather forces, sunshine, rain, everything. Now, the physical forces in the universe control things like landforms, geology. They're all multiple interacting different forces. When we design something, we don't design allowing things to happen like that. We design with a goal in mind. We design with a client in mind. We don't allow things to happen dynamically. Now, of course, when we design buildings, and as an architect, he knows all about this, we can't design buildings like Hogwarts, where the staircases move all the time. You never know where you're going to end up if you've ever watched Harry Potter films. That would be not practical. We design things with an end point in mind. And that's the difference between the way nature works and the way we work as designers. Our brains, and that's my brain, so you said you had one, it's proven, are known to be something that responds to the self-similar patterns of nature. Our brains, scientists are now thinking that our brains themselves are highly self-similar. The way they work is highly self-similar. And the fact that we've grown up through eons with all the self-similar patterns of nature, it's easier for us to interpret those patterns. And that's one of the reasons why, there are many reasons, but that's one of the reasons why we find the patterns of nature so beautiful and so refreshing and so relaxing. But the randomness of nature is something that's very hard to incorporate into designs. It's a process that is very difficult. So I tried an experiment. I said, okay, and this I read a paper in 1976 by Hillier, wrote a paper, something along these lines, and I thought I'd try it out. Say as a designer, we have 4 items you want to put into a space. 1, 2, 3, 4. They all have a little entryway, and they can't be moved. The rules are, it has to be as compact as possible, and you maintain clear access. Of course, the simplest way is a linear process, where you create a grid block structure. It's easy to do, you only need to use 2 of them. But what if we actually said, okay, let's change another thing. Let's say no 2 elements of the same can be next to each other. And the next number you choose is random. I used a random number generator. And look what sort of pattern you end up with. Now, the 2 different patterns are completely different. The random pattern is much richer and much more complex. But does that really mean anything? Does it actually signify that it's closer to nature? When you look at the overall form of that, you get these 2 ideas. And then when you look at the number Mandelbrot uses to characterise nature versus urban, you see you get a fractal value, 2.38, which is low, and the random one is quite a high fractal value. And this struck me as being very similar to the way we design our environments. The square grid block pattern you see everywhere around in the cities we build today. The other pattern you tend to see more in the older cities. This is a photograph of East London. where it's a bit more organic, it's a bit more diffuse. You can't really, you get big spaces going down to small spaces, going down to big spaces, going down to small spaces. It's not random, it's not linear in that concept. And when you look at how those compare with my other environments, you can see the linear environment is way down below small emission. The other one is right up near Regent's Park. That doesn't mean to say it's copying nature, but what it means is that incorporating a bit of randomness into our lives, you can actually start to create things that mimic the forms of nature, and possibly even start to bring the beauty of nature back into our everyday environments. It would be wonderful if we could live in places where, as soon as you walked out the door, you were in an environment that you felt relaxed everywhere. Not just along the Esplanade, not just on the beach, not just in the forest, but in all our urban environments. If 6 out of 10 people in the world are going to live in urban environments, we can no longer build urban environments that encourage people to be stressed or they don't relax them. Patterns are incredibly important. Patterns in the process is incredibly important. And if that doesn't convince you, I'd like to show you 2 examples of why I think that's the case and how they change the world. Everybody in this room will probably have a mobile phone. That's a free grab, I'm not breaching copyright, from Wikipedia, of the evolution of the mobile phone. The only reason why everybody in this room can have a mobile phone which fits into their pocket is because of self-similarity of nature. The aerials of your mobile phone are not big Cumbersmith you pull out, they've actually been created on something called the Sierpinski gas. And you can see that it's very similar to the Romanov broccoli. The fact the more you zoom into it, the more similar the pattern gets. And that has changed the way we communicate. If that hadn't been thought about, you wouldn't have mobile phones you could fit in your pocket. Let's look at another example. In 1960, a guy called Licklider wrote a paper in America. He was a psychologist and a computer scientist. And he wrote a paper called Man-Computer Symbiosis. And of course, in 1960, computers filled the room. He wrote a thought paper. He envisaged a world where computers took over the role of libraries. And these computer centres were linked up around the world. And then he said, when people would link into these computer centres through their own computers via some kind of leased landline was the word he used. He wrote that paper in 1960, computers filled the room. How many people would have believed him? How many people would have said, yeah, you're right, that's going to be possible? They would have laughed at him. But he envisaged the internet we have today. In 1969, 2 universities in America accepted the challenge of trying to create that. Universities and research scientists and scientists in general are known for collaborating. In fact, it's probably true to say, my wife Robin is a scientist, that no scientific breakthrough could happen today without true collaboration between scientists around the world. These guys at UCLA and the Stanford Research Institute in 1969 got 2 computers to talk to each other. They were on the phone. One side, I've just typed L. Did you get the L? Yes, we got the L. Typed O. Did you get the O? Yes, we got the O. Typed G. Bang, the system crashed. From that one idea in 1960 to that one test in 1969, how many people have mentioned Google today? TED would not exist if the internet didn't exist. It's completely changed the way we are. Back to my cup of coffee. A lot of people have spoken about change today, and a lot of people have spoken about ideas. And we're all about ideas. I like to sit in my corner and think of ideas, and I never think anybody's going to be interested in it. But I'm here today talking to you about my ideas of how we can bring randomness back into our lives, to create more beauty in our lives. Because beauty is known by psychologists to be incredibly important for adaptation and change. And it's incredibly important for us to develop deep feelings about our environment around us. If anybody has an idea, don't be like me. Don't be afraid to share it. Go out and talk to somebody. Go out and tell people, because you never know what's going to happen. You might not have the idea. You might have the idea now, and you might not be the person to take it further forward, but somebody might. And that one idea, if one idea comes out of this today that can help change Fraser Forest, or even change the world around us, I think that's an amazing outcome. So thank you very much.